We're going to cover probability questions, and in probability, most of your problems are going to say you're picking one random person, but that one is not something that should go in your answer. So when we find probability, we're always going to set it up so that we have a fraction where the event that we want is on the top, the number of ways to get that event out of the total possibilities. Okay. So even though we are just choosing one person, there's multiple people that could meet that event. So in this case, we're choosing one person from a survey about what kind of ice cream they like. So our first question, what is the probability they like chocolate? Well, on this graph, there are 107 people who like chocolate ice cream. So that's the number of people that meet that event. And that becomes my numerator. The denominator is the number of people that we're choosing from. So in this survey, there were 269 people, and that is going to be my denominator. Now you could change this to a decimal or a percentage, and your test will even ask you to, but if you put it in as a fraction, you will still get it correct. So just leave it as a fraction and move on to the next question. What is the probability I pick someone from this group who happened to be a teenager? So I'm looking for how many total teenagers we have. There's 73. And we're still choosing from the whole group, so this is over 269. Our next question, what is the probability I get somebody who likes vanilla and this intersection symbol? Remember, we call that one and, okay, because we can make that into an A. So I want to pick somebody who is an adult and they like vanilla ice cream. So this is, our keyword here was and, but it's called an intersection. And on the graph, the intersection is where the two concepts cross each other on the graph. So I'm looking at vanilla, and I'm looking at adults, and right here where they cross is the number of ways that I can get an adult who likes vanilla ice cream. But I'm still choosing out of the entire group, so this is 54 out of 269. All right, our next question. What is the probability that I get someone who neither likes chocolate nor vanilla and they are a teen? So here we have that intersection or and again. So I'm looking for where do those two things cross? So I take all of I follow the teens, I follow the neither, they cross at 45. So my probability is 45 out of 269 people. Our next question, we switch over to a union problem. This is an or. I'm going to count everyone who likes who is a child in this survey, or they like vanilla ice cream. Now, when we learned about or on our set notation, the key word that we used here is combine. We want to combine these values together. So we're going to get rid of this really quick. Okay. When I do a combine problem, I'm going to start by taking the first thing, so all of the children. So we're going to take this 77 over here, but then we all want to combine it with the people who like vanilla. Okay. Now there's a couple of ways to do it. I like to start with this total children and then add in the teens who like vanilla and the adults who like vanilla. So this is 77 plus 16 plus 54. So that gives me 147 that are either a child or they like vanilla ice cream. Okay, same idea on this next one. This upside down U means or combine those things together. So we're going to take all of our teens plus the other people who like chocolate. that looks like 73 plus 40 plus 55. By adding them together in this way, we're making sure we don't double count people, but also making sure we include everyone that we intended to include. So this comes out to 168 over 269. So notice on these problems, all of them were out of 269, or the grand total of people that were surveyed for the table. As we move into the next questions, you'll notice that the denominator changes on each question. Anytime you see this symbol right here, that tells you that we're using a different total and not the grand total. The part that comes last is what should be on your denominator. So in this problem, it's asking, what is the probability I pick someone from the survey who took a Spanish class if they were a boy? We know we're just talking about the boys, or whatever comes last. This is the only part of the table that I'm looking at. Okay, whatever's last is going to go on your denominator. So there are 20 total boys. On the top of your fraction, we want to use the boys who took Spanish. So 10 out of 20, or a 50% chance that they took Spanish if we already know it's a boy. On this next problem, okay, the part that's on the bottom is the part that is your denominator. So the girls goes on the bottom. So there's 30 girls. Of those girls, 3 of them studied German. So 3 out of 30 chance that if I pick the person from this group and I tell you it is a girl, they take a German class. On this next question, we're not going to put girl as our denominator because that's the first part of the question. Instead, we want to put the number of students who studied French in our denominator. So I'm just looking at this part of my graph. Okay. There were 14 students who studied French, and 12 of them were girls. So 12 out of 14 chance, if I know they studied French, that it is a girl. All right, we did talk about mutually exclusive. It won't be on your test. Mutually exclusive just means 2 events that cannot happen at the same time. So boys and studying German are not exclusive because those can both happen at the same time. All right, the last question here on our review today is taking one of these problems and making our two-way table. So our two-way table here tells us 240 people took this survey. Okay, 240 people took the survey. So that is going to be our total, and it goes down here. Okay. 21 males prefer SUVs. Okay. Okay. Male and SUV. And 45 of 84 people who prefer sports are female. So this part right here, 84 people who prefer sports cars, and then 45 of them are female. So everything that I have in green here on my paper is information that I pulled from the statement given to me. The rest of this I'm going to do in red, and this is stuff that we had to figure out using addition or subtraction. So I can figure out this box right here because the grand total people surveyed is 240. 84 of them like sports cars. So if I minus those 2 numbers, that tells me 156 people surveyed prefer SUVs. And again, if I go back the other way and add these 2 together, that should give me 240. All right, I can now figure out this spot right here because I know the total. 84 people liked sports cars. 45 of them were male, so we subtract 44. That means 45 of them were female who preferred sports cars, so 35 of the males prefer sports cars. Okay. Now I have both of these boxes, so I can find my total by adding these together. which tells me 60 total males were included in this survey. And I can figure out this box right here by subtracting 156, the total SUV preferences, minus the 21, gives me 135. I can add here, and that gives me 180. And then if I double check myself and add this direction, 60 plus 180 gives me 240. Now, the biggest mistake I see on this is instead of using addition and subtraction, we take the values that are given to us and cross them. So if I put an 84 right here, I want to put an 84 on one of these rows over here. And you can see that from our answers, we didn't get an 84 over there. What I always do is I start by putting down everything that's known. And I did that in green, so then I know everything in red is what I calculated myself. Okay. Then you have to use addition and subtraction so that your totals all add to the right numbers. All right, that is all for this review. If you need additional help, please ask some questions in class.